Welcome back. Today we are diving into an exciting project, a Bluetooth based voice control robot built with an ESP32 microcontroller. Imagine controlling a robot just by speaking, no remotes, no buttons, just your voice. Perfect for hands free automation, assistive tech, or even just a fun DIY project. Stick around us as we break down how it works, the components used, and how you can build one by yourself. The robots are awesome, but controlling them with remotes or joysticks isn't always practical. What if your hands are busy? What if you need accessibility features? That's where voice control comes in. This project solved that by using Bluetooth and an ESP32 to turn spoken commands into robot movements. Simple, low cost, and super initiative. So we followed design thinking to build the robot. Users need hands-free control. The challenge was enabling voice activated movement. We compared Wi-Fi, apps, and Bluetooth, but Bluetooth won for low power and smartphone compatibility. Built with ESP32 plus L298 motor driver and 4 DC motors. The robot responds to commands like move forward or turn left flawlessly. So next we will build one prototype that is voice control robot. ESP32 receives voice commands through Bluetooth module. Command processed and mapped into the motion like forward, backward, left, right or stop. L298 motor driver is used to control the motors according to our commands. The components used in this project are ESP32 development board and L298 motor driver module, DC motors, chassis module, robot chassis, 12-volt battery and battery pack, and jumper wires to connect the to complete the connections. Here is the pinout of ESP32 development board. It has 30 pins. Some of them are ADC, which is the analog, and also the digital pin. Next is the L299 motor driver used to control the motors. Here out 1, out 2, out 3, out 4. It should be connected to the motors and these are connected to the microcontroller. Here 12 volt ground and 5 volt is connected to the battery pack, and we need the chassis for the connections and the 12 volt battery pack for powering up our circuit. Here is the simple circuit diagram. To ESP32 the motor driver is connected via IN1, IN2, IN3 and IN4. Motor 1, 2, 3, 4 is connected to the out 1, out 2, out 3 and out 4, and 12 volt battery is connected to the motor driver. So let's see how it works. The magic happens in 3 steps. You speak a command into your phone. The ESP32 receives it via Bluetooth and decodes the action. The L298 driver spins the motors accordingly, whether the command is forward or backward or left or right. If the host, if the user say forward, the chassis will move forward continuously until he say stop. The applications of this voice control robot is many as you think. One of these is assistive robots for people with disabilities, smart home helpers, or in education, or in even in events or museums. Let's dive into the code for this project. This is the simple code for voice control robot. As you can see that we are using Bluetooth serial because we are using a Bluetooth module. It has included with one library called Bluetooth serial.h, and we have connected 4 IN inputs of motor drivers to the ESP32. IN 1 is connected to 18, GPIO 18, IN 2 is connected to 19, same as for IN 3 and IN 4, 21 and 22. Here we need to create one object from the library included. Next, in the void setup, we need to set up the inputs as output or input. We are it is the output device, the motors, so we are setting up as output device. Next, for no more errors, we will write one function called stop motors. It will stop all the motors if any one of them are running. Next, in the void loop, we are checking that if any command is available in Bluetooth, it should be stored in command variable, and if there are any white space remaining or the new line is there present in the command, it should trim it and save into one single word. Next, execute voice command. This will go up to next function. Here we have wrote if move forward. If the command is move forward, then move forward function should be run. Same as for if move backward was the command, then move backward function should be run. Same as for turn left, turn right and stop. Next, we will see what we have written in move forward. In move forward, IN3 and IN4, both back wheels should be turned on, and we are given 135. 135 is the speed of our chassis. You can also reduce it or you can also increase it as per your requirements. Same as for backward, left, right and stop motors. In stop motors, we have given it at 0 because no motor should be turned on at this time. So this is the code. Let's dive into the connections and just check the output once.
So hello everyone, today we will be learning the connection of the voice controlled robot. So let's start the connection. So here you can see these are the positive and negative wires of the of all the four motors. So let's connect the motors into the L298N motor driver. I have just connected the wires for 12 volt, like 12 volt ground and 5 volt. I have taken the 12 volt red of the which is positive connected to the 12 volt, white with negative to the ground, and from that same ground I have taken the male jumper wire to connect to the ESP32 and 5 volt to power the ESP32. So here let's connect these pins wires to the out pins of the L298, which means out 1, out 2, out 3, out 4. So let's connect it. So as the connection of the L298 motor driver with the motor has been done, so let's connect to the ESP32. This is an ESP32 in which it has inbuilt Bluetooth, Wi-Fi, so you can use it for Bluetooth control voice control robot. So first of all, we should take the common ground and 3.3 volt here. It's okay if we didn't take because we don't have any sensors in this. It controls only 3 by ESP32 motor driver. So let's directly connect. Let's start the connection of L298 motor driver with an ESP32. So connect these 4 pins to the IN1, IN2, IN3 and IN4. So yellow is the IN1. So IN1 will be connected to the pin 18 of the ESP32. 18. Here you can see the names as D23, D12, D21. So connect to the D18. And IN2 will be connected to the pin 19, which will be the green pin 19. IN3 to pin 21. And IN4 to pin 22. And also the 5 volt from the motor driver will be connected to the pin pin of the ESP32 5 volt to power the ESP32 and ground to the here it is the ground. These both are the ground. So ground to the ground of the ESP32. So after connecting this, dump the program in the ESP32. After program has been dumped in the ESP32, so remove the USB cable and then power like this. So after dumping the program, so just power the remove the USB and then connect the 12 volt battery. So this turns on. So don't forget to don't forget to sort the enable A and enable B. There will be an enable A and enable B in the L298N motor driver. So connect both the first and the 2 pins. This is back side of that pin also. Sort it like that for enable A also. Enable A to as the connection has been done, so let's check the output.
Go ahead. Go back. Go ahead. Left. Go ahead.